All right, today we're going to do 7.4 notes, which is the unit circle in 45 degrees on page 13. We're going to find the trig ratio of 45-degree triangles in the unit circle. So in the unit circle, we have every radius is the length of 1. However, I'm going to use the fact that all circles are similar, and I'm going to change that to make these problems easier to answer as we move forward. So if you think of this as 0, and we rotate it 45 degrees, that would be this part right here in our unit circle. So 45 degrees is right there. It creates a right angle with the x-axis, where this angle is 45 degrees. We learned that in a triangle that has 45, 45, 90, the legs are equal. So I'm going to name each of the legs the length of 1. That would make the hypotenuse 1 times the square root of 2, which is the square root of 2. If this is the origin of our circle, notice this is going right, which is positive, and this is going up, which is positive. The hypotenuse is always positive. The second place you'll see 45-degree reference angles is past 90 degrees but less than 180. It's at 135 degrees. You can draw a line to the x-axis, creating a right angle, where if this is 135 degrees, the angle inside the triangle is 45. Since this is a 45, 45, 90, the legs are both 1, and the hypotenuse is the square root of 2. However, this leg is going left, so that would make that a -1. This is going up, so it stays positive, and again, the hypotenuse is always positive. If you keep going around the unit circle past 180 degrees, another 45 degrees makes 225 degrees. You draw a line up to the x-axis, creating a right angle, where this is 45 degrees more than 180. Since this is a 45, 45, 90, the legs are both 1, and the hypotenuse is the square root of 2. Notice this is going left, which makes it negative. This is going down, which makes it negative. But the hypotenuse is always positive. Finally, this would be 270, keep going, we get to 315 degrees. If this is 315 degrees, that would make this 45. So we can draw this down to the x-axis, creating a right angle, where this angle is 45 degrees, which would make both of the legs 1, and the hypotenuse the square root of 2. This is going right, which is positive, but this leg is going down, making that leg negative. Again, the hypotenuse is always positive. So number 1 says to make a sketch of the angle, find its reference angle, then evaluate the function without a calculator. So we're going to draw our unit circle starting with a T. Our angle is at 45 degrees. Well, that's less than 90, so that's going to put us in quadrant 1. So you're going to draw this in and connect it to the x-axis, where this is 45 degrees. We learned that 45 degrees, the legs are both 1. The hypotenuse is the square root of 2. Starting at 0, 0 here, this is going right, which is positive, up, which is positive. But now I have the word sine in front. That means I have to find the sine ratio using SOHCAHTOA. The sine ratio is opposite over hypotenuse. So the reference angle is always at the origin. The side opposite of that is 1. And then the hypotenuse is the square root of 2. So it's 1 over the square root of 2. You have to rationalize this. So if you remember, the number on top stays on top. The square root of 2 is going to move up, and then the number comes out of the root on the bottom. So this becomes root 2 over 2. For B, draw a T, 135 degrees. If this is 90, this is 180. It's between 90 and 180 right here. Then draw a line down to the x-axis. If this is 135 degrees, that means the angle has to be 45 degrees. The legs are 1. The hypotenuse is the square root of 2. Going left is negative, up is positive. Secant is the reciprocal of cosine. Remember, they're always backwards from each other. So that would mean this is h over a. So the hypotenuse is the square root of 2 over the adjacent side to my reference angle, which is -1. This simplifies to negative root 2. For C, draw T. We have 90, 180, 270. 225 is more than 180, but less than 270. So we can connect this to the x-axis. 225, that's 45 degrees more than 180. Our legs are 1. The hypotenuse is root 2. Left is negative, down is negative. But the hypotenuse is always positive. So we're looking for the cosine ratio. Cosine is cut, A over H. So from my reference angle, the adjacent side is -1. The hypotenuse is the square root of 2. We have to rationalize, so it becomes -1. Moving the root 2 on top makes it negative root 2 over 2. For D, this is a negative degree. That means I'm going to go clockwise. Less than 90 degrees, I'm going 45 degrees, which is about here, connected to the x-axis. We rotated 45 degrees, so that's our angle. The legs are 1. The hypotenuse is the square root of 2. Right is positive, down is negative. We're finding the sine ratio, which is O over H. So from my reference angle, the opposite is -1. The hypotenuse is root 2. So this rationalizes to negative root 2 over 2. For E, 405 degrees. So we have 90, 180, 270, 360. We have to keep going. If this is 360, that would make this 450. So notice that's less than that. So it's more than 360, but less than 450. Draw a line, connect it to the x-axis. This is 45 degrees more than 360. The legs are 1. The hypotenuse is root 2. Right is positive, up is positive. To find the tangent ratio, it's TOA, O over A. So from this angle, opposite is 1, adjacent is 1. 1 over 1 is 1. Now we're going to go in the negative direction. So we're going to go clockwise. We have 90, 180, 270, 360, 450. You have to keep going. So another 90 would make 540. So it's more than 450, but less than 540. So it's going to be here. Connect it to the x-axis. This is going to be 45 degrees. So that's going to make the legs 1 and the hypotenuse root 2. Left is negative, down is negative. We're finding secant. Secant is the reciprocal of cosine. So it's H over A. So the hypotenuse is the square root of 2, and the adjacent is -1. If you divide root 2 by -1, you get negative root 2. All right, so now we're going to do all of this with radians. We're going to convert the degrees into radians and then complete the unit circle. So if you remember, we multiply the degree by pi over 180. That'll make the degrees cancel. So this is going to get me 45 pi over 180. And if you reduce the fraction, you get pi over 4. If you multiply 135 by pi over 180, you get 135 pi over 180, which is 3 pi over 4. 225, you multiply by pi over 180, reduce the fraction, you get 5 pi over 4. You try 315. And you should get 7 pi over 4. All right, so since 45 degrees is pi over 4, and we know every 90 degrees is half a pi, a quarter of a pi is halfway to half a pi. So that's going to be here in quadrant 1 in our unit circle. So notice my angle is now labeled pi over 4. I'm not labeling it 45 degrees, I'm labeling it pi over 4. 135 is 3 pi over 4. So it's more than half a pi, less than a full pi. So that's going to be over here. Again, the angle's pi over 4, which is 45 degrees. But now this is going left 1, so that's a negative 1. Okay, 225 we said was 5 pi over 4. If we write it as a mixed number, 4 goes into 5 once with 1 left over. So it's 1 and 1/4 pi. So it's more than 1 pi by a quarter pi. So it's down here where both legs are negative 1. 7 pi over 4, notice as a mixed number, 4 goes into 7 once with 3 left over. So it's 1 3/4 pi. Almost 2 pi, almost all the way around the circle. Adjacent is 1, opposite is negative 1. So to do these, you make a t, but we want to write this as a mixed number. So 4 goes into 5 once with 1 left over. So this is the same as 1 and 1/4 pi. So when you draw your t, now you know where to go. So if it's half a pi, 1 pi, 1.5. Notice that's less than 1.5, but it's more than 1, so it's going to be down here. If this is 1 pi, what's left inside is a quarter pi. This is equivalent to 45 degrees. That means I'm going to label the sides with the legs of 1 and the hypotenuse root 2. Left is negative, down is negative. Now we have to find the sine ratio. Sine is so over h. So from my reference angle, opposite is negative 1, hypotenuse is root 2, and then we rationalize and get negative root 2 over 2. Notice this is an improper fraction, so we have to write it as a mixed number. So 4 goes into 11 twice. That would be 4 times 2 is 8, with 3 left over. So 2 3/4 pi. So every 90 degrees is half a pi. We have half a pi, 1 pi, 1.5 pi, 2 pi. We have to keep going. This is 2.5 pi. Notice this is more. 3 pi. So it's between 2.5 and 3 pi. So if this is 3/4 of a pi, that would make this 1/4 of a pi to complete the full pi. Again, this is equivalent to 45 degrees, so the legs are 1, the hypotenuse is root 2, left is negative, up is positive. Cotangent is the reciprocal of tangent, so we're going to flip this. It's going to be A over O. So from this angle, the adjacent is negative 1, and then the opposite is positive 1. Negative 1 divided by 1 is negative 1. For C, now we're going in the negative direction. Notice 4 does not go into 3, so I can't write it as a mixed number. So we're just going to draw the T. We're going to go clockwise. So this is half a pi, 1 pi. It's more than a half a pi, less than a full pi, so it's going to be here. If this is 3/4 of a pi, the angle inside is 1/4 of a pi. So my legs are 1, the hypotenuse is root 2, left is negative, down is negative. Again, the hypotenuse is always positive. Cosine is cut, A over h. So from this angle, adjacent is negative 1, the hypotenuse is root 2. You have to rationalize and get negative root 2 over 2. You try D. So hopefully you got this answer. The sine ratio is O over h. So notice you had to write it as a mixed number. 4 goes into 9 twice with 1 left over. So you have in the negative direction half a pi 1, 1.5, 2, and then it's another quarter of a pi past 2 pi. And this would be your picture. O over h, negative 1 over root 2, which is negative root 2 over 2. Try E. All right, so as a mixed number, this would become negative 3 pi over 4. So that would be half of pi 1, 1.5, 2, 2.5, 3 pi, 3.5. Notice it's less than 3.5, but more than 3, so it puts it over here. And then cosine is cut, a over h, so you should get negative root 2 over 2.